Okay, so tonight we are talking about square roots and cube roots. And no, these are not things you find under the ground with plants. These are mathematical roots. Let's talk about square roots for a second. A square root is when you take the square root of a number, basically, you're looking for a number that when multiplied by itself gives you the original number back. So, for example, the definition is this for square roots. Let's write this down. Square roots. If x squared equals y, then x is a square root of y. That means if I take a number and I square it and get a number, then the original number is back. Okay? For this particular lesson, we're going to talk mostly about perfect squares versus just anything. And we'll talk about the other ones also a little bit, but numbers like 9, 36, 64, those are all what are known as perfect squares. Perfect squares. And you should know the following perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, and then it's helpful to know 400 and 625. Those don't come up in order. And we'll talk a little bit more about these, but when you see these numbers, you should be very familiar with these numbers. Square roots use a sign, or to indicate a square root, we use what is called a radical sign. Well, it's called that because it's just that cool to use it. I know you laughed at that. The radical sign. Radical sign. The radical sign looks like that. Almost like the division sign, but it's got a little check mark at the end there. So for example, if I ask for the square root of 30, let's go back here, not 6, but the square root of 36. If I asked you for the square root of 36, I'm looking for a number that when multiplied to itself will give me 36. Well, we all know that is 6. If I said to you, what is the negative square root of 36? Well, here we look at the square root of 36, which is 6, and then we add a negative sign onto it. Sometimes I might do this, plus or minus root 36. There I go again, root 36. Well, in this case, that means it's plus or minus 6. The one thing you have to be careful, you can never take the square root of a negative number. Because try to find a number times itself that will give me negative 36. You see, you might say, oh, well, 6. Well, 6 times 6 is positive 36. Doesn't work. Oh, negative 36. Nope, same difference. Negative 36. Let's see, negative 6 times negative 6. Well, that's negative times negative is a positive. That gives me positive 36. So I can't do, and if you say, well, 6 and negative 6, that's not the same number. So here, there are there's no answer for this one. Or we say there's no real solution. We'll talk a little later on this week about what the answer really is when you have the square root of a negative number. So go ahead, I want you to try these for me. Square root of 9, negative square root of 64, plus or minus the square root of 100, the square root of negative 49. Stop the recording and try those problems. All right, let's see if you got them right. Square root of 9, 3. Negative square root of 64, negative 8. Plus or minus root 100, plus or minus 10. And the square root of negative 49, did I catch you? I hope not. No real root is what we actually say. And that's the way you should write it for this problem. Sometimes we just can't find the square root. Square root of 33. Well, I don't think there's any number that will fit the square root of 33. Well, there is, but it's some long number that is a decimal that never ends, so we don't want to do that. So what we do is this. To figure out what the square root of 33 is, we actually we're not even going to estimate it. Well, we're going to kind of do an estimation. Here's how this estimation goes. We're going to start with the actual number 33. And I'm going to ask you, what two perfect squares is 33 between? And we're going to write that down like this. Write it down, write it down. And we know that 33 is between 25 and 36. Now what I'm going to do is take the square root of each of those numbers. Well, the square root of 25 is 5. I don't know what the square root of 33 is. And the square root of 36 is 6. So it turns out that the square root of 33 is somewhere between 5 and 6. But then we follow that up with, what is it closer to? And in this case, we find out that the square root of 33 is actually closer to 6, because 33 is much closer to 36 than it is to 25. Okay, you try this one. What is negative square root of 79? Estimate it, tell me what it's between, and then tell me what it's closer to. In this case, let's just look at 79 for a second. I know 79 is going to be between 64 and 81. And I know if I take the square root of all those, I get 8 is less than the square root of 79, which is less than 9. But remember, I want a negative. Now remember, if I multiply this by a negative number, or by a negative 1, remember, multiplying by a negative number changes the directions of the inequalities. So it's between negative 8 and negative 9, and it's closer to negative 9. Now, one of the things we'll talk about also today is cube roots. And when we're talking about cube roots, where in square roots we were looking for one number that multiplied by itself gives you the number, in cube roots we're looking for numbers that are multiplied to themselves 3 times. Cube roots are written like this. That is a cube root. And if I wanted, for example, the cube root of, say, the cubed root of 27. So if I'm looking for the cubed root of 27, I'm looking for a number that multiplied by itself 3 times will give me 27. Well, you probably guessed it by now. That is 3, because 3 times 3 times 3 is 27. Now, one of the unique things about cube roots is that cube roots can, in fact, be negative. For example, if I did the cube root of negative 729. Well, the cube root of 729, negative 729, we'll just think of 729. Okay, it's not that easy. These do take a little bit of thought and work on it. But in this case, it is equal to negative 9. Now, the reason you could do a cube root is because a negative 9 times a negative 9 times a negative 9 will give you a negative number. The first two negatives will give you the positive, but the third one will make it negative again. So it is possible to take the cube root of a negative number. Can we estimate cube roots? Yes, exactly the same way that we did square roots. If you're looking for a couple of cube roots of perfect cube roots, 1 is a perfect cube root because it's 1 times 1 times 1. 8, which is 2 times 2 times 2. 27, 3 times 3 times 3. 64, which is 4 times 4 times 4. 125, which is 5 times 5 times 5. And then I'll let you continue from there to look for other perfect cubes. And tomorrow in class, we will talk more about this and look at more examples and try to do some classwork.